Hey everybody, I'm going to show you a little bit of mp2 today, and this is from the hints. So I'm going to go on my Mac this time, log in through my terminal, see if I can SSH. SSH is built into the Mac, so I just open up my terminal, and this will allow me to go ahead and key in the address like I would PuTTY in Windows. And let me put my secret password. And there I am, and I'm going to get into my directory, mp2, and what I want to do is copy in my command, including the dot up to the dot for 171, let's say for an example. And then if I do ls there, it gives me the starter code. So I'm going to open it up through one of my favorite editors, mp2. And then we'll see that we have some of the basic code there to iterate through and perform some numerical analysis, CCAT method for the root of this here, the determinant. And we have some input starting points, A and B. So that's the two values we're going to enter in. And then the message of success or failures when we approximate the root given a certain number of iterations. So what we do is use some of the variables that we're going to need, and we'll continue with some values that we input here for the variables. This is going to be, it looks like, variables. Let's see what the example here is down further. It's going to be for values here, A and B. Okay, and right there it's going to say input those values for A and B, right there in a comment. So we're just going to make sure we're going to prompt the user always to do that, because we want to be able to go ahead and at least always let the user know what's going on, what values, and then show the grab the data from the keyboard. And you notice that C++ allows you to do one item space and then another item, or one item space enter and then the other item, and they'll store every time in the respective variables. So if I do a 0, it'll store an A, and if I hit enter and hit a 1, press a 1, it'll then store in B. And continue on with these other examples. Java does the console, Fortran does the read, okay? And of course, anytime we prompt in Java, that would be our system.out statement. And when we prompt in Fortran, if you notice, we can use the write statement, as we see in some of the scripts that are given in the hints. So run through this, and the main thing is that it's pretty straightforward. It's going to give you something that will be right there, pretty easy to go ahead and do. So we'll just copy this in. I sort of combined these steps together. So really that's like a combination plate there. You know? So I can just delete that, Control U if I want. And you can always paste that back in. Control K to delete, and Control U if you ever wanted to paste it back in or undo. So Control K to delete at a certain line or certain lines, and Control U to undo. So actually I combined the 1 and 2 if you notice here. I could have separated that out, but the user will see what they need to see. Then we do that, calculate A, calculate B, Y sub A rather, Y sub B, no problem there. And we make sure that when we enter that in, we're going to go ahead, we're going to go ahead and make sure that we line things up a little bit, be nice and neat, and then put our formulas together. Notice A and B are very similar, how we do those calculations. So actually Y sub B will be very similar to Y sub A. So we're just going to go ahead really and just do that Y sub A part with a little trick here. Copy the other one in, and this time we're just tweaking out the B values in order to derive our approximation with our CCAT. Counters for sort of helping us through the loop and see how many times we iterate. And we have what's called a forever loop in Java and C++. That helps us at least to continue until we have a break statement. We encounter a break statement, and then we exit out of that break statement. In Fortran, we just do a do loop, And we start with a do, which always goes through its body one time, and then we go ahead and sort of will exit out when we need to with a statement there. So we just go ahead and say, okay, I want to make sure that we are going to enter some points, and then after we enter the points, we're going to go ahead and we're going to then allow for exiting within the do loop if some if statement is going to trigger if some condition is met. And then with Fortran, make sure we do the end do there, okay? So that encompasses the looping with Java and C++. We have the bracey at the start of the loop and the bracey at the end of the loop. It's always good to put little comments into end for loop so you know, or end do loop so you know yourself a little bit, perhaps when you encounter so ending points. Make sure that, oh, okay, I'm covering myself. I know that I have an opening left brace, let's say for the language, and a closing then right brace to encompass all the lines that are within here, okay? All right, cool. So I'll work these out. And the main thing is that when you are doing this, make sure we have all our if statements. Make sure always we have our semicolons at the end of assignment statements in C++ and in our Java language. Okay, and make sure we enter in the rest here and put the calculations in and sort of following the patterns here. We give you some good hints the first few MPs, and then make sure we also have at the designated areas there, we sort of are lining up with the comments there, what number to point to in a comment, and then we're going to put in our if statements every time to make sure that we have something that's displayed in case we need to display it, and also we break out at some point too as well. Okay, doke. So make sure we include that there. Okay, doke. And the main thing is after we notice we update before we end the loop. We do an update on some of these values here because we want to be able to succeed very carefully at reassigning, if necessary, our variables because things interchange, they reset, they reassign. So we want to make sure that we cover our act there by doing so. You know? All right. So we got some of these there that we're reassigning. Make sure we are assigning something that's the right order. If something has to be changed beforehand, then we go ahead and include it. So we don't want to have anything incorrectly overriding one variable versus another. So those sort of buckets change. The A bucket, the YA bucket, the B bucket, and the YB. So when I go back up in the loop, anything that has maybe something with that Y sub A, the A or the B, any of that stuff is going to be looked at maybe in a different light, okay? Especially if we're doing something with processing or we're doing something with display, all of that in case we have our test met. And then at the end, we're just going to go ahead and include our last approximated root value, which is going to be given here a little bit. We have to figure out what we want to do there. And the main thing we want to do, of course, is to show a display. Well, our count is just going to be what that count is, right? We're going to put in something that says this is our last count. And we know our last count is going to be whatever that was the ending point, from our count variable, right? So we know we loop so many times. And notice inside the loop interior, we put in that count plus plus. Same with Fortran. We want to be able to make sure we increment the variable. And that will help us, again, to know exactly how many counts we have. Fortran would be doing probably count equal count plus 1. But in Java and C++, we could shortcut that in one sort of shortcut assignment. Count plus plus would really be count equal count plus 1. Either way, it works fine. Okay, doke? And then please make sure we show our last iteration. I'm going to do an end L. Make sure we do end L for new line for instead of a backslash n. That makes sure that we do sort of a new line for display. And also, please don't put N1, you're going to get an error. it's easy to see that as a 1 instead of an L sometimes on the font. And then you're going to go ahead and display your outcome, please, for the remaining search approximation value, your last approximated outcome. And which was what now? Okay, we want to be able to put in something that's going to be where I started, where I stopped, okay? We know that we have these variables here. So one of these variables here are going to be shown as what is the last value that we see in display, okay? And of course, the root of that, okay? So please make sure to sort of have the root value here and what was the last approximated value. So as you notice, we do print something here. Make sure it's a nice printout, just for your own self and for myself when I tested, that we see the C value. So notice the C value is this one of the values that's going to be shown for the approximated loop result there. So you know that one value is going to be C, right? That's the approximated loop right there for the root. That's going to be there. And then you want to also output one of the outcomes there, which is that negative 1.003838 times 10 to the minus 06 or 006. So that's going to be also the additional value that you're going to sort of see. And you can put that nice sort of makeup on there, things in parentheses, the comma, and the values, of course, of C, and then whatever is going to be this value here. And it's going to be a hint, one of these variables, okay? So make sure we put that mysterious variable in over here. And then, voila, we're done. Put something like that in. Hope this helps. Take care, everybody. Thanks for watching.